Okay, question 6 of term 2 control test. So, they tell us the reaction of zinc and excess dilute hydrochloric acid is used in the investigation. In other words, zinc determines how much product I get. The balanced equation is given, so we've got zinc plus 2HCl goes to zinc chloride plus 2H2. The reaction conditions used and the results obtained for each experiment are summarized in the table below. Now, if you look at it, they're looking at concentration, volume, surface area temperature, and then reaction rate. So I know it's rates of reactions, okay? And you look, they changed concentration, they kept volume the same except there. They also changed the state of division. They changed temperature over there, and here was a very big change in concentration, but then this concentration and that concentration is the same. So we need to consider that altogether. Then they say the same mass of zinc is used in all the experiments. So in other words, we get the same amount of product at the end. The zinc is completely covered in all reactions, and the reaction time it takes for the reaction to be completed. Experiment 1 and experiment 3 are compared. So if we look at experiment 1 and 3, they want the independent variable. In other words, what was changed? 5 and 2. If you look at everything else, it all stays the same. Don't worry about this. That was your dependent variable. So what was changed? The concentration of the acid. Okay. Then they say write down the value of X in experiment 4. And now some of you go, but how are we supposed to know? Watch here. Let's just take this. Okay. Do you see that this was 15? This was 15. Okay. Granules. 25 degrees, 25 degrees. Difference. And this is what they wanted you to get to. 200, 400. The volume doesn't make a difference. Volume does not affect rate. Volume may affect how much product we get, but considering they said to us that the HCl was in excess, that volume is irrelevant. So basically, experiment 2 and experiment 4 are the same. That means that's going to be 14. Okay. Then, oh boy, now they say the Maxwell-Boltzmann energy distribution curves for the particles in each experiment 1, 3, and 5 are shown below. Identify A, B, or C that represents the following. First one is experiment 3. If I look at experiment 3, the big difference in experiment 3 is that the concentration was very big. Concentration means I have lots and lots and lots of product. So watch here. A and B, those two graphs, have the same average kinetic energy. Okay, the peaks at the same value of kinetic energy. B is much higher. That means for B, there's far more particles because the area under the graph will be bigger. Alright, so experiment 6.3.1 is B. Why? Because there are more particles per unit volume. Concentration, don't forget, per unit volume. Okay, because that's how we know. Then they want experiment 5. Now experiment 5, higher temperature. What do we know about the graph? At a higher temperature, it goes flatter and wider. I've got a higher kinetic energy. So 6.3.2, C is experiment 5. Why? Because the particles' kinetic energy increases. Okay, and more particles have sufficient energy, and I'm pretty sure you're struggling to read this, but just go with it. Okay, now we get to the graph. The learners performed the experiment again and plotted the graph of the experiment for experiment 1. So here's our graph. First thing it says, use the graph to calculate average rate for the first 30 seconds. Now the first 30 seconds is to here. That means I want the gradient of the graph. It's close enough to a straight line. Okay, we take an average gradient. So the rate of the reaction is the change in volume over the change in time. So I'm going to take this point and 0. Take the 0, but you have to put the 0 in. If you don't, you're not showing me a change in. You're showing me a point. That doesn't help me. It's got to be, rate of reaction means it's got to be a change in time. Time has to change. It can't be a specific point because we're not looking at an instantaneous rate. Okay, so 60 minus 0, 30 minus 0, which gives me 2. And the units, we have, this was in centimeters cubed. So this becomes centimeters cubed per second. Okay. Please be careful. Many of you lost marks over here because you didn't put the minus 0. So that's really important, okay? 6.4. Why will the rate of the reaction at 50 seconds, so over here, be less than at 30 seconds? Well, it's slowing down. Why is it slowing down? Because the reactants are being used up. So for 6.4.2, you can either tell me the reactants are being used up, which is what's happening, okay, or you could tell me the concentration of the reactants is decreasing. Concentration of the reactants decreases. I'm using things up. The less particles there are, the slower the reaction's going to go. Okay, big thing was the graph and understanding the table.